Welcome to OpenHive.JS, the podcast for all things JavaScript. We are your hosts, Matteo Collina and Snell.
We as open source developers feel the pain of having to rely on centralized solutions more than big companies do, and more than users who don't really care about where the data lives.
Welcome back for part 2 of our conversation with Mikeal Rogers, IPLD Lead at Protocol Labs and Node and JavaScript thought leader. In this episode, our chat with Mikeal continues with a look at the open source model, decentralized databases, and ESM. If you haven't already, check out part 1 to see where the conversation began.
When you say now we're using a decentralized database, the entire application stack between the database and the application, all the GraphQL, all the REST services, everything that people are used to and how they build applications, all that has to get replaced. That's a lot of code to write. We've got a lot of work to do.
Let's get into it. This is OpenHive.JS from Nearform.
Yeah, as you're sitting here talking, I just keep going back to how similar, at least the high-level concepts are to the original arguments for semantic web and linked data, W3C. Yeah. It all goes back to the same fundamental idea of a core set of primitives. In the semantic web case, the URL, right? It doesn't really matter where these things are actually stored, where they're at. We can still get at them in a consistent way. So it's interesting that we have come largely full circle back, and yet again, Tim is right. Was right. This is where things go.
Yeah, I mean, so Tim was right, and then
no. Sorry, folks. Let me intervene here. Tim was absolutely right, and then the implementation was not okay.
About the problem.
Absolutely wrong. Yeah.
Yeah. So Tim diagnosed the problem. Tim diagnosed this problem, I think, around the time that I started programming. He started talking about this in the 90s, right? He was saying the big thing that we missed in the web was the data layer. There's no data layer. We need to figure that out, because the way that everybody is now building their data layer is to centralize it in a database off of the web. So let's figure that out. I think that the solution that he came to was the solution that you would come to if you invented the URL too. If you invented literally the most important thing ever, you would be like, hey, that's probably the right solution to this next problem. But the issue with using an URL for the data layer of the web goes beyond just kind of centralization, decentralization. It's not a stable enough primitive because it can mutate, right? So you don't have assurances about it. And so you can't actually build the data structures that you would build a database on top of the semantic web stack. Instead, what you end up doing is you end up using centralized databases, literally using graph databases, and then serializing to semantic web protocols. So the same way that you're publishing a human readable version of the web, you are publishing this machine readable version of the web that is the serialization of the database. And I think that that doesn't get us out of the bag a billionaire problem, for one. It doesn't actually kind of break apart the centralization of the data itself. It just gives us a decentralized access to it in a way. But also I just don't think that there is a clear incentive to build a human readable version of your website. And so you will take the thing that is in the database and turn it into a website, because that's what people will see. There's an incentive there. The incentives for building out that data layer are a lot harder to quantify. It's a lot harder to see the value that people get out of it. And you can kind of see this in the rise of and fall of APIs that big services were doing, right? Where it became very in vogue for everything to have a REST interface. And when a lot of new companies were starting, everyone had to have an API, because that was how you tied all these services together and how you built additional value and how these different services were going to take off. But once enough of them had done really well, they started to really lock down those APIs and remove that functionality because they didn't actually want this network of services. They wanted more people pulled into their ecosystem that they kind of could derive value from. And so if you want to avoid that problem, you actually have to attack the value generation itself. You have to go like, where is the value being created? And that's in the relationships. And then you have to break that apart. And the thing that I keep coming back to is that like, I think that once we have the right tools, once we have like things that open source developers and web developers can just grab and build applications this way, I think this is actually like a way easier battle to win than we think that it is. I think it's really easy actually to dislodge a Facebook and a Twitter and all of these services. I think that they're actually very, very weak because they are a silo of value generation that is going to have to compete with a network of value generation. Once you have a network of value generation, it's just over. Like now all new applications are being built on that network. Because why wouldn't you, right? Like, so here's a really good example. If there was like a decentralized data structure for tweets and tweet feeds, and there was a system already that people were using to kind of look at those tweet feeds. If I wrote any new audio application for podcasting, something that it would do would be to publish into that network. Something that it would do would be to read out of that network to figure out what I want to listen to, right? Like there's just no, like, why wouldn't you, right? Like you get to write a new application and then basically bootstrap on top of all this value that's already being generated in this network. You want to be a participant of the network because there's so much more value there. And then as your application becomes valuable itself and creates all this new content, it is then leveraged by the network going forward. And so I really think that like these are very easy problems to solve once we do the actual hard part, which is writing all the code and the tools for developers to be able to write applications this way, which I will be fully honest, we do not have. Like a lot of people that are really into decentralized applications have this very like condescending attitude towards web developers where, why aren't you writing things this way? Why aren't you already writing DApps? Why isn't everything DApps? And it's like, because there's like 4 DApps. And this is like not an application model that is highly accessible to web developers yet. We are still figuring out what the best way to write these are. And like, you know, I'm involved in that and I'm invested in it, but like we have work to do.
Now, is the bootstrapping problem there the tools and you know the inability for developers to easily create that, or is it the current lack of users to motivate developers to go off and build things?
I think it's mostly developers. I really do. Like the average, so like if an open source project gets to a point where, or I should say a JavaScript project, the average JavaScript project, it gets to a point where they want like a website and they're not just a GitHub repo. That website usually has a better than average design. Like the user-facing portion of that is better than average. If you look at the average enterprise application or just the average like application being built, like it's pretty clunky and it's just kind of grabbing a bunch of existing toolkit widgets and shoving them together. You know, we have this view that these user problems are like really difficult to solve, and that's why we need these big companies that have these big focused user departments that are really thinking about the user experience. But when you really break it down, the number of companies that have user experience departments like that are really few and far between. Like, yes, the biggest applications have them, but there's no reason to think that, one, you wouldn't attract that kind of talent and those kinds of people in an open source project. Like I've seen people like that flock to these kinds of projects. Like they actually are attracted to them. If you structure an I mean, I've done, as you know, like a lot of governance work and a lot of thinking about like how an open source project can attract people at different ends of the talent spectrum, other than just, you know, the core competency of working on this code base. And once you open the door to those people, they show up. I think that the open source model of building applications is just a fundamentally better model. And the things that it is not currently good at have nothing to do with the model not being a good fit. It has to do with like our lack of maturity around tools and primitives for open source development to take on those kinds of problems. I don't think that there's some kind of critical bit that open source is missing where it can address user concerns.
Yeah, I see success of projects like Signal. Signal communicator, is being an example of that, where it can be done in a decentralized model where you don't have the centralized data storage and user profiles and all this kind of stuff, but it still just works. And and then I look at things like the situation with what's happening with TikTok right now, right? With the U.S. government threatening to to shut them down and kind of force stuff, and it'll be really interesting for to see developers go off and like take a look at TikTok, take a look at Signals, and say, you know what, maybe we can do something in a completely decentralized way that has encryption, that does have a really good user experience as well, right? It just works the way it's supposed to work. I mean, I'm excited to see that kind of stuff really start to take off. But the challenge has always been that how do you give users something that works really well, right, and meets these concerns, right?
Yep. I mean, I think like my goal, like the state that I'm trying to get, like the maturity that I'm trying to get this technology to, is not to the point where like everyone is a decentralized node on the internet. Like that's like a 10, 20-year goal for me. My shorter term goal is just getting to the point where an open source project can build a user-facing application that is like the scale of TikTok or Twitter, and it is ostensibly in GitHub Pages, where it is like a static website where all of the application code is being produced that way. It's an open source project, everybody contributes, and when you log in, you connect a data provider to that. And that's where the actual data storage goes. And that's like not that hard of a place to get to. Like it's actually just not as difficult as we think.
Mikeal, like most of the time that I'm spending these days while doing like some coding work is mostly related on solving the head of line blocking problem in applications, drivers, and so on. So the future you are describing, it seems like so far ahead than what I'm working on normally that it looks a little bit futuristic. I don't know. It's I would love to not have that problem, but we are still faced, like most developers these days, most applications are still built around the concept of connection pools, head of line blocking, and a lot of those pipelining, whatever. And a lot of those big problems. So I don't know.
We've bottlenecked on our centralized infrastructure. To the point where we spend most of our time just trying to solve the one problem we created for ourselves. Your point there about it being so futuristic. I have to laugh at it because going back to the point about Tim earlier, this was the problem that was identified like 20 years ago, 30 years ago. So it's both a historical problem and a future problem, and we haven't quite got there yet.
So look, at a primitive level, I think I did already kind of solve this problem, to be honest with you. Like I really do think that we have the solution to this, and we don't have the tools on top of it to get where we need to go. Like I have the primitives to build something like MySQL or MongoDB in a decentralized way with decentralized providers. And because of the way those primitives work, the problem that you're talking about is kind of already solved at the primitive layer, right? So when you build with these content address structures, so imagine a B tree that you build for your database, and all those pointers that used to be in like a page file format that pointed at different sectors of the disk. Instead, those pointed at these CIDs, right? Like these hash-based addresses. That means that all of the blocks in the database are not in like this linear storage structure on disk, but they're just in a key value store, and literally in any key value store anywhere. So I have a local offline cache that's a key value store. I have, I could talk to Cloudflare, and Cloudflare could be fronting like, with just an HTTP based key value store where I'm asking for these addresses. And then eventually I can ask for these addresses out of other centralized providers or out of a decentralized network. So the database just turns everything into blocks, and then we get those blocks out of the key value store. And now you're just talking about, okay, what is the most efficient way to parse this graph and figure out what blocks that I don't have and ask people for them? And that's not that hard. Like I already have like implementations of like 3 or 4 different approaches based on kind of what your graph looks like. In the Filecoin blockchain right now, there is a protocol called GraphSync that is used for retrievals, where we have like a selector-based syntax for getting all of these. Like, so if you have a point-to-point protocol and you know what the graph looks like, then you can pull it that way. DagDB has a very different approach because there's a huge amount of deduplication across the graphs. So what it holds onto is like an indexing structure over all of the blocks that it has, so that it can very quickly, without parsing the whole graph, figure out what are all the pieces that I'm missing so that I can ask a provider for them. And so now the protocols for getting the blocks and handling all these head of liners is like, those get really easy. We can do really cool optimizations to those. And because these are all hash-based key values pairs that you're asking for, doing things like you just have LRUs everywhere, right? Like you have an LRU literally in memory in the client. You have an LRU, like you have a local offline cache that effectively functions as an LRU. If you want to just expire things in it, you can talk to any CDN provider. Edge becomes very, very easy in this model because every edge node now just has all these key value pairs, and all of the parts of a data structure that you're accessing all the time are always going to be in the local LRU. And when you update the structure, you're only updating the pieces that changed, and all of the parts of the entire graph and the entire tree structure that have not changed are the same and are still in the same cache at every edge node, at offline cache, at everywhere. So to me, that's the thing that we get for free. That's not the hard problem to solve. Like, once we use these primitives, like, that problem goes away almost for free. And now we have to move on to, okay, now we have to write like replacing all databases ever is a really big challenge. Like, that's a big enough problem for us to get our heads around. I think that this issue is fairly easy. Literally never using a centralized database again, it tears apart the whole stack. Like, we really can't underestimate how big of a deal this is. It's not just that I lose MongoDB and I lose MySQL, I lose like whatever my favorite database is. It's literally the fact that the way that I build an application now is that I do a REST service request or like a GraphQL request or some kind of transactional request. And when I say write data and that returns to me, there is a guarantee, a write guarantee that literally you can trace all the way to an fsync call on disk for a B-tree structure in that centralized database. Like, how we handle transactional integrity of applications boils down to the implementation of centralized databases. And so when you change that, when you say now we're using a decentralized database, the entire application stack between the database and the application, all the GraphQL, all the REST services, everything that people are used to and how they build applications, all that has to get replaced. And that's a lot of code to write. Like, we've got a lot of work to do. It's a big enough problem. And if you want to think like, hey, this is out far in the future, like, that's the reason why it's far.
Yeah, it's, I don't think we can overstate how difficult that is going to be. And if we start taking, and then beyond that, we start taking a look at the code itself, right? Not just the data that you're moving around, but the code that's operating on that. And we start trying to apply some of the same ideas and the same models. It's like, why do we necessarily have to install a module at development time? Why can't we, when we need a piece of functionality, go out and find it, and apply it?
Ooh,
right?
I've been working on that too.
And that's I know you have. I know there's work that's going in that direction. Just that itself is also going to be so very transformative to the way people write code. So, how much of this problem do we tackle now, or do we have to spread it out over time for people to actually be able to start using it?
So I think that the past is a pretty good guide here. If you look back at the technologies that we have adapted to in the technology industry, like if you look at the ways in which we build applications and the things that we have adopted, they are leading indicators of a lot of larger user changes. Not every user change, right? Like, it doesn't predict the iPhone, but it does predict like Slack and messaging, right? Like, I was using IRC in the 90s to be a part of online communities, right? Bulletin board systems before that. We have all of these things that like nerds and people that work on technology had adopted. If you look at the early work on online collaboration, which is now literally the way that everyone works, especially during COVID. It kind of accelerated this. But even before COVID, like the direction that everything was going in is that the work that you are paid to do as a person is becoming highly collaborative, and you're using online tools for that. We've been doing that in open source for a very long time. We've been improving those tools over time. And so, and GitHub is a really good guide here. GitHub really is a leading indicator of all of this. Clay Shirky did a lot of the early work on kind of peer-to-peer production networks, and open source was like his guide for how to think about that. And open source kind of leading into Wikipedia. This is all, really early stuff. This is like, early 2010s. And so I think that like our first targets really should be ourselves and these early development communities, and we shouldn't focus too much on user-facing applications and kind of jump the gun on that, because we'll get much tighter feedback cycles if we focus on ourselves and on other developers. And I think that we are feeling this pain earlier than other people are. Like we as open source developers feel the pain of having to rely on centralized solutions more than big companies do, and more that users who don't really care about where their data lives really see as well. So I think that like thinking about this from the point of view of like, okay, how do I decentralize just our workflow, or how do I give us better tools that can show value? Like there's a lot of value locked up in these primitives just themselves. So how do you like get developers kind of accustomed to them? So like something that I've been working on is the Esm transition. And we can talk about how bad this is going to be if you want. But oh boy. So ESM, it's a really big change. It's a really big breaking change. I think that people are a little bit too accustomed to the way that we build web applications right now. And the way that we build applications right now is less than 10 years old. This whole, like, you have a bundler, and you have a framework that is really tied into that bundler, and you have this value network of like NPM modules to pull stuff in, and that is like disconnected from the build and then deployment environment of the application. That's all very, very new. If you go back before that, the big thing in web development, the big thing that happened was Jquery, which was like a rejection of that, right? Jquery is a script that you include in the header of your website. And that was like how you included things just on the internet. You leveraged the web network. But at a certain point, just we had too many dependencies to really rely on that. And it wasn't a great kind of publishing model. And so what we ended up doing was kind of grafting the web development experience onto the NPM and Node.js ecosystem. And then that meant funneling everything into these bundlers. And so bundlers have serious performance issues that are not like, oh, the bundler is slow to run, but literally the fastest that your website can ever load on updating the website is the full cost of the entire bundle. That's not going to work. Like I'm just saying right now, like that's not an application model that we know will work in the future, because we know that people are going to write more code in the future. We know that applications are going to get more advanced in the future. And the web platform has done a tremendous job of keeping up with needs and shedding the need for a lot of this ecosystem and a lot of the need for these modules. But we're not going to move to a model in which you use less of other people's code, or you pull in less dependencies. We need to move to a model in which like those dependencies, yes, are becoming less necessary over time, but where we can optimize the performance, the load performance, and deduplicate pulling in stuff that we've gotten in the past.
Right? Yeah, I think anybody that's just seen how much more complex web development has become just from even 10 years ago, or or even 5 years ago, right? Understand it's like we're only going to be adding more code.
Yeah,
it's only going to get more complex. And you're absolutely right. ESM it completely changes the model. And this is a large part of the difficulty why it's been so hard getting it into Node, because it's like, how much of a disruption do we want to bring in? We really didn't want to have a Python 2, Python 3 situation, right? Where it was just such a difference.
Yeah. But I mean, one thing that I should say though is that something that's kind of overlooked is that because the way that we build applications is through bundlers. We overlook the fact that we have this thing called universal JavaScript before ESM. Yeah. And even though people think that they're using ESM because they're using import statements that then get changed by the compiler, yeah. Like they think that they have ESM and they have universal JavaScript, where like they you can write code and have it run in Node and have it run in websites as one kind of thing. And ESM is different enough from CommonJS and changes the representations that you need to make when you're translating between these two parties enough that Node couldn't implement it cross-compatibility both directions. So it could bring CJS into ESM, but it can't bring ESM to CJS. Right. And you can't get access to all of the new features and this new potential way of building web applications that newer tools like Snowpack are allowing you to do unless you write things in ESM. And so what we have to figure out now is, okay, how do I write ESM and then have that be universal JavaScript that can run everywhere? And that's actually going to take a compile step. It's going to before publishing. So you're going to have to compile out a CommonJS version of your package. And that's something that like Node developers have never had to do and that we haven't had to think about as part of this kind of universal JavaScript story. But I've worked on some tools for that already. I have a new one coming out. Right now I'm just solving this build problem, right? Like I just like all I want to do is I want to write my little libraries and I want them to work everywhere. That's all I want. And that's like, if I'm doing that with ESM right now, I like that doesn't work. So right now I'm just writing a little build tool that you can use to write pure ESM, and then it will compile out a target that you can then publish to NPM and it'll just work everywhere. Nice. But the sort of the layer in between here that I'm working on that will be like a step on top of this is that what I really want to do is use that as a way into a new form of package management. So it'll still work and you can still publish it to NPM, but I want you to be able to publish that package in its native kind of format to a different kind of packaging system that thinks about packages as a data structure. So instead of packages being like this, the way that NPM works is that you have this config file, the package.json file, and then you have a bunch of other files like in a tarball. And the only way to reason about what's going on here is to literally parse the package.json, and then if it's CommonJS, you actually have to parse the files and execute them, because like it's very hard to figure out what is happening in CommonJS without executing like really complex algorithms for resolution. Whereas with ESM, that's not the case. With ESM, you can just parse the AST and figure out everything that's going on, which is really nice. But I want this whole package, like what I do with your code before I turn it into this thing that then works in NPM. That logic should be captured in a data structure and then that published as its own entity. And then we can now do things in package management with interlinking and dependency management that we couldn't do in the NPM model. We can literally hash link, statically link between different packages. And that means that in the browser, we can start to do incredible performance optimizations. So if you have a package that is literally a hash link graph, right, of all the files that you're ever going to pull, the moment that you request this package and you say, and you give me no e tag, I can HTTP push you every file that you're going to have. So it's literally one request, and then just like a bundle, but it's separate web requests, I can HTTP push you everything that you ever needed. If you then come back later and you say, oh, here's my e tag for the old version, I can compare that against the hash for the new version of the package, and I can figure out exactly all the files that changed. So I can now like at least prefetch, if not just push you, all the files that changed.
Right, and only the files that changed.
And only the files that changed.
Yep.
Yes. And that's the kind of thing that you can do with these like hashlink data structures that I've been working on. So now we can like take our actual code and package it up. And we have this really cool browser flow, but you can take it a step further. So this is like very experimental. Like I'm just kind of poking around at this, but Dino has some really nice security features. You can really lock it down. And some of these are making their way into Node now as well. And so we're getting much better at kind of sandboxing stuff. Actually, this guy that I work with, Rockley, he figured out a really, really great sandboxing model in Iframes where you actually can kind of safely load JavaScript code into an iframe and give it access to nothing and just talk to it over a predetermined kind of communication channel. So we have all these kind of sandbox environments for JavaScript. I started to think about, okay, what if I take a function, a JavaScript function, as an ESM module, and I put it into this packaging format? So now I have a hash for the package and every one of its dependencies. So I have the whole graph of information that you're going to need to ever execute it. So now I have a hash that I can pass off and say, hey, now this is just the address for this function. So I can have a serverless environment that is just dynamically loading any function that I ever need by its hash. And I can start, like, literally now I have a static linking mechanism in serverless environments and in distributed computing that is just hash based. I can take that same hash, and if that function conforms to a standard that we say this is what HTTP functions should look like, then it could also work as a service worker. And it's just the same code running as a service worker, running as a serverless function. If we say, you know what, here's how to pass options to it, like a command line flags, and you reconcile that with what an HTTP function used to look like, you can say, oh, now we have a registry of names and hashes for every command line application that's ever existed in this registry. You can start to do really, really cool stuff.
Right. Yeah.
You can even do stuff like you can start parsing all the files and creating like a shadow graph of all the files and parse the files into AST and then turn the AST into a hash link graph. And then you can literally look across the entire ecosystem and go, what code are most people running? Like, how often do I see each of these hashes?
Right. It just comes to mind, a few other really interesting things. Once you start parsing it into AST, you could also do translations between languages fairly easily. So, run it as JavaScript in one environment, WASM in another environment, Rust in another. There's really, you're right. There's really interesting things you could potentially do. On that note, we are running up to the end of the time. This has been absolutely phenomenal conversation. And you're talking, I know we could probably go on for another hour at least. What we might do, invite you back for another episode, and we can just kind of keep hammering, keep riffing on this stuff.
Yeah.
But for now, I think we're going to go ahead and end here. Just as a reminder to listeners, you can find OpenHive.JS on Apple Podcasts or on Spotify. You can find other players, go to anchor.fm/OpenHive.JS. You can find other places to listen to us. Want to thank Mikeal for joining us, and thank you all for listening.
Great.
This has been another episode of OpenHive.JS, the podcast for all things JavaScript from Nearform. Be sure to subscribe to OpenHive.JS on your favorite podcast player. Join us next time for more insights and opinions from the open source and JavaScript communities. Until then, I am Matteo Collina. Thanks for listening.